Well, thank you for taking the time to attend today's presentation. Over the next 45 minutes or so, I'm going to fill your mind with some of the latest discoveries from the Cassini-Huygens mission to Saturn. I'm part of the Jet Propulsion Lab Solar System Ambassador Program, and there's about 500 of us across the country. I think one of the few requirements to be a Solar System Ambassador is an interest in space and a desire to learn. And so with the help of JPL, I've trained myself on this mission, and I'm excited about sharing with you what I've learned. If you're interested in becoming a Solar System Ambassador or want to learn more about the program, contact me after the program, and I'd be happy to share some information with you. I want to start with a little bit of background information about the Jet Propulsion Lab itself. It is a real place. It's the lead research and design center for NASA. Once a year in May, they have an open house. Many of the buildings are open, and it's really a great way to see all the science and all the different missions that are going on and being planned. So here's where we're going to go for the next 45 minutes or so. First, I'll talk about the spacecraft and the journey to get to Saturn. Second, I'll talk about the planets, the rings, and the moons. And then lastly, we'll take a ride down on the Huygens Probe and land on the surface of Titan. So I'd like to start out with a little bit of background information about the two astronomers this mission was named after, namely Huygens and Cassini. Huygens first discovered Titan in 1659 through a homemade telescope. And really ever since he discovered Titan, what's down on the surface of this giant moon of Saturn has been hidden from us. The reason for that is because Titan has a very thick, dense atmosphere. Very rare for a moon, and it blocks us from being able to see what's down on the surface. Huygens in 1655 discovered Titan, and as you can see, he also discovered a hairstyle that became extremely popular for rock bands in the 1700s. In 1659, he published his Systema Saturnium, where he speculated on what we might find on the surface of Titan. I did recently read that Huygens was a follower of numerology and believed that with the discovery of Titan, our universe or our solar system was complete. He stopped a little bit early. There are now 62 different moons of Saturn. This is Cassini. This is the other astronomer this mission is named after. He made a number of important discoveries, including the Cassini division. So this is an obvious gap in the rings that he was able to first discern. He also discovered the moon Iapetus as well as the moon Rhea. And interestingly enough, when he was making observations of this moon Iapetus, it disappeared from his observations. And in the process of trying to find this moon again, he discovered the moon Rhea. And at that time, he actually correctly speculated that the reason Iapetus disappeared from sight is that half the moon is very, very dark and half the moon is very, very light. So when the dark side is facing towards Earth, it can't be seen, and when the light side is towards Earth, it can be seen. And we'll go over the details of this very different moon in a few slides. So that was Cassini-Huygens, the astronomers. This is Cassini-Huygens' spacecraft. You can get a really nice idea how large this spacecraft is. There's some people down here working in clean suits, kind of give you a nice perspective. The entire spacecraft was tested in this test module, which was able to test the extreme cold, and also Cassini, on the way to Saturn, flew by the atmosphere within the atmosphere of Venus, so it also had to be tested for some rather high temperatures. This is one of my favorite images of the Huygens-Cassini spacecraft under construction, because it reminds me just how many people and all the disciplines that went into making this mission happen. Here you can see this person's fitting the Huygens probe with this Kapton insulation material. But again, it makes me think of all the different disciplines: hardware engineer, software engineering, biology, chemistry, mechanical engineering, all the different disciplines that caused this, that were required to make this mission happen. So this is the Cassini spacecraft. It has two engines, one primary, one secondary. For fuel, or for power, it uses 3 radioisotopic thermoelectric generators. It's a little too far out in order to use solar panels. And up here, you can get a really nice idea of the main dish antenna and this long magnometer boom. Cassini was launched in 1997. It was a nighttime launch. And you can see this fantastic image of lifting 2.2 million pounds from Earth's gravity. I have gone out to see some amateur rocketry, so if you're interested in learning more about amateur rocketry, get with me after the program and contact me. But it must have been really something to see 2.2 million pounds being deadlifted from the Earth's gravity. I really like this particular image. You know, these towers here give this kind of Godzilla movie kind of feel to things. And this is a really nice image. Believe this is a Cape Canaveral boat. And you can see here the exhaust fumes here, and then what's really neat is the reflection down here on the water. Okay, so here's where we're going. We're going to Saturn. It's a sixth planet in our solar system. It's about 888 million miles from the Sun to Saturn. And in order to get to Saturn, Cassini couldn't just fly directly there. It would have had to carry an enormous amount of fuel, and it would have never been able to get off the ground. So Cassini had to use this concept of gravity assist. And that's the concept where a spacecraft flying towards a large body like a moon or a solar system uses the massive gravity, or the mass of a planet, to accelerate it and pull it towards it, and gathers enough speed and almost picks up speed for free. And Cassini did this a number of times in order to get to Saturn. Right here is the Sun, and you can see the orbit of the Earth, the orbit of Venus. So Cassini launched in 1997, did a half a lap around the Sun, and had that energy exchange with Venus. Used Venus's gravity to pick up some speed. Did that a number of times. Cassini maxed out and hit speeds of up to 42,000 miles an hour using this gravity assist method. Flew by Jupiter and ultimately arrived at Saturn in 2004. I spoke of this energy exchange as not being for free. I recently read that a spacecraft that used gravity assist with the planet Mars flew by Mars to accelerate, get a little something for free. It altered the orbit of Mars by the width of an atom, and after a couple 100 million years, it will throw off the orbit of Mars by about an inch. So it is not for free. There is a tiny, tiny impact on the planet or moon that's being used for the gravity assist. On its way towards Saturn, it flew by Jupiter, and it took this gorgeous image of Jupiter. I've heard Jupiter's atmosphere described as liquid marble. And in this particular image, it caught the moon Io, and you can really see this really nice shadow of the moon Io. I want to point out that Io is one of the few geologically active moons in our solar system. And at any point, it's spewing out 1 metric ton per second of material into the Jovian atmosphere. And also in this Jupiter image, you can see the great red spot that's on the order of 300 years, or it was discovered at least 300 years ago. Now, Cassini is not one stationary orbiter, and it's unlike the Voyager spacecraft that in the 70s that just flew by the gas giants. Cassini went to Saturn, is at Saturn, it's still at Saturn, and it's in an excellent state of health. Its original four-year plan, and its mission has been extended numerous times. Also, I want to mention that Cassini is not making kind of just these perfect circular orbits or geosynchronous orbits. It's actually changing its orbit every lap around using Titan's gravity to adjust itself and making different observations and going at different inclinations to make observations of the rings, the moon, Saturn. So with 62 moons, you can see that the Saturnian system is a very complex system. This upper panel here just kind of gives you an idea of the diversity of the size, shape, and color of many of the moons of Saturn. This giant moon here you can see that's Titan. That's the one that the Huygens probe was released from the Cassini spaceship and ultimately landed on the surface of Titan so we could see what's down there. As I mentioned, ever since Huygens, the astronomer, discovered Titan, what's down there has been hidden from us. And this lower panel, you can get an idea just of Saturn itself, the rings, and many, many moons. You can see there's a number of moons here that are within the rings and moons way out that spread all the way out this way. I do want to mention that Cassini, the spacecraft, flew up in this direction from the southern portion up through this sparsely populated section of the rings, and it actually turned its high-gain antenna just as a safety precaution in the area just to make sure it wasn't hit or damaged by anything. But this is a very sparsely populated section of the rings. And also the other spacecraft that visited the Saturn system, such as Voyager, did the same thing. They flew up in this direction from south to north. The Saturn itself, including the rings, would fit nicely between the Earth and the Moon, approximately 250,000 miles. The rings themselves are millions upon millions of individually orbiting objects. Some the size of boulders, some micron, just very, very tiny. The rings themselves run edge to edge are about 188,000 miles, but edge on, even though they're 180,000 miles wide, edge on, they're less than 100 feet thick. Saturn is a fast rotator, so a day on Saturn is about 10 hours. A year or a lap around the sun is 29 years. And it's mostly sun-like in composition, mostly hydrogen and helium. Now this particular image is a Voyager image, it's not a Cassini image. But this is when I was first exposed to some of the ring effects and the different shadowing and lighting effects that Saturn has with rings. So in this particular image, the Voyager spacecraft is leaving Saturn. It's going on to explore other gas giants in our solar system. And the sun is actually on the right-hand side of this image. So we're kind of looking back with Voyager at Saturn. And this is when I was first exposed to some of these lighting effects. So you can see on the right-hand side, you have the sun shining light on Saturn, and the rings are actually casting a shadow on the planet here. And then Saturn itself is casting a shadow on the rings. And this is a Cassini image of the similar kind of ring effects. And you can see these rings at 180,000 miles end to end, but less than 100 feet thick, edge on, they appear paper thin. So you can see some tiny moons embedded in these paper thin rings. And down here is the sun is shining light up through Saturn's rings, and the details of the rings are being shown and displayed on the northern hemisphere of Saturn. Since I mentioned Voyager, the Voyager spacecraft are still going. They were launched in the 70s. They are still on a mission, and they have power to on the order till 2020. They are on a mission to discover when our solar system ends and when outer space truly begins. Voyager 1 is about 9 billion miles from Earth, and that's about 2.5 times the distance from Pluto to the Sun. The Cassini spacecraft listened or made measurements of the electromagnetic waves of Saturn, or the electromagnetic energy. And it's kind of fun. What they did is they compressed it and shifted the spectrum so we can hear them audibly, and they're rather fun to listen to. So this is the Cassini's recording of Saturn's electromagnetic energy. Very fun to listen to. Every time I hear it, it puts me in the mood to rent the movie Forbidden Planet. So Saturn itself, temperature-wise, the cloud tops are about -310 Fahrenheit, and the warmest spot, the South Pole, about -188. One of the things that the Cassini spacecraft found, which was completely unexpected on Saturn, was a giant, persistent hurricane at the South Pole. This is unlike any other gas giant in our solar system. It's about 5,000 miles wide, about 45 miles deep. If it was on Earth, it would be something like, I don't know, a category 200. So that was the South Pole of Saturn. On the North Pole, another phenomenon unlike any other gas giant in our solar system. There is a persistent hexagon-shaped feature on the cloud decks of Saturn. It's about 15,000 miles across, and it rotates at about the same speed as Saturn. And you can see here in this image, this is an infrared image so you can see the details a little bit better, but you can see this hexagon shape, first discovered during the Voyager mission. And then here is a more recent image. This is this rather spooky, persistent hexagon cloud feature, unlike any other gas giant in our solar system, first discovered in Voyager, but beautifully imaged here by Cassini. So that was Saturn itself. Let's go ahead and take a look at the rings. Now, I don't want to underestimate Cassini and Huygens, the astronomers, but I'm not sure they had in mind or could have imagined this kind of beauty. Just some beautiful pastels and just the variation of the rings themselves. They are named in order of discovery. So this is the D ring, C ring, B ring. This is the Cassini division. This is that division that Cassini first was able to discern, and ultimately the A ring. Now, if you took all of these individually orbiting ice rock particles that make up the rings, and you squash them together, they would account for about 16% of the mass of our moons. Gives a pretty good idea just of how much material that makes up the rings. Now, this particular image is a Saturnian eclipse. So in this image, we're back here with Cassini looking at Saturn, and the sun is highlighting and illuminating the rings in a rather fantastic perspective. I believe that a new ring was actually discovered from this particular perspective, and it really kind of shows another unique perspective on the beauty of the rings. Now, there is a little white dot that's back here, right here, and believe it or not, that's Earth. So next time you're outside, remember to wave to the Cassini camera. There are moons within the rings, and the moons have various impact on the rings, and this is a nice kind of illustration of some of that impact. In this particular image, everything in this image is going from right to left. And over time, this little moon, I think the moon is Daphnis, has carved out space. And so when particles get really, really close to this moon right here and here, the particles are attracted to the moon, then the moon kind of disturbs it. But because the particles, everything in this picture is going from right to left, and what I pretend to know about orbital mechanics is that objects that are closer to a celestial body will be orbiting faster than the ones farther out. The perturbations or disturbances that this little moon Daphnis has created are actually passing up Daphnis. And the Daphnis, since it's second closest in this diagram to these ring particles, which are going again right to left, Daphnis is actually passing up the perturbations it made. So in this particular image, there's 3 macro speeds. The top are, these particles are the fastest, Daphnis, which is in the middle, is the second, and then the third, or the slowest piece, is here. This is a nice little short video compilation. I like this one because it shows just how thin these rings are. Cassini is sliding from south to north in this particular imagery, and the rings actually blink out for a second. Just paper thin. That was Saturn and the rings. Let's go ahead and take a look at some of the moons. So this is Mimas. This is what we call the Death Star moon. You can see that obvious gigantic crater. Whatever hit this moon, if it was any bigger, it would have blown this moon to smithereens. From what I've read, this is the largest crater relative to the size of the moon in our solar system. This is Enceladus. This is the brightest moon in our solar system. So our moon reflects about 10% of the light. Enceladus is very, very bright. It's a near perfect reflector, reflecting close to 100% of the light that's shown on it. One of the things Cassini found was something very, very rare, which was very few impact craters. And you can see from this image there's something going on this moon. I don't believe these are alien snowmobile tracks. This is evidence that there's geological activity on this moon. And that's what Cassini found. Cassini found another geologically active body in our solar system. I've heard these geysers described as cosmic old faithfuls. So Enceladus is spewing out water vapor into the Saturn system. And here's a really unique perspective. Here are these ice geysers spewing out water vapor, and you can see Titan in the background. Now, with use of other instruments, land-based telescopes, as well as other NASA equipment, they've started to put together a model on what's causing this. And I think of it as similar to the moon of Jupiter, Europa, where there's a rocky core, and because of the elliptical orbits, that rocky core is churning and warming, and is creating a warm liquid ocean underneath this ice shell. And when conditions are right, the ice shell cracks, and it spews out these geysers of water vapor. Okay, so let's go ahead and take a look a little bit past Titan itself. Let's take a look at Iapetus. So this is the moon that Cassini first discovered. And you can see from this panel, the half of this moon, very, very dark, half of this moon, very, very light. And that's what Cassini originally speculated on why it was disappearing from sight. One of the things that was another unique discovery to Cassini, and this is not science fiction, so it has, at about the equator, it has an 8-mile-high ridge. It's approximately around the entire length of the moon itself. And you can see here, this is a close-up, that this 8-mile-high, about 800 miles, almost all the way across Iapetus. And you kind of think, you know, what if this ridge was on Earth? You know, how it would impact, you know, travel across from north to south. Jet airplanes wouldn't be able to fly high enough. Okay, let's go ahead and take a look at Titan. So this is what Huygens first discovered, and ever since this mission, what's down there has been hidden from us. This is what Titan would look like flying by in a spacecraft, just this giant orange, yellowish ball. Can't see what's down on the surface. The temperature of Titan is minus 290 degrees Fahrenheit, which is very important because methane and ethane, which are other chemicals on Titan, at minus 290 degrees Fahrenheit, it's just right for those to be at a liquid. So, comparing Titan to other bodies in our solar system, on this top panel, we have Mercury, Venus, Home, and Mars. And you can see that Titan down here in this panel is a little bit smaller than the planet Mars. In terms of comparisons to other moons in our solar system, this is our moon, this is Io, This is that moon of Jupiter that's spewing out all the material. It's got all the active volcanoes. This is Europa. This is a moon that's very similar to Enceladus, whereby there's a liquid ice, there's an ice shell. And when I was at a recent JPL open house, I talked to a couple of mission planners. Ultimately, what we want to do is we want to sink down under that ice and send a swimming aquabot to see what's down there. And the primary focus for the upcoming missions is where's the thinnest part of the ice and what technology do we use to melt through and get down there. And this is Ganymede. This is the largest moon in our solar system. So Titan ends up just a little bit smaller than Ganymede, the largest moon in our solar system. Three important things to remember or think about regarding Titan. First, Titan's atmosphere extends 5 to 7 times higher than Earth's atmosphere. Second, Titan is mostly nitrogen and some traces of methane. Third is at minus 290 degrees Fahrenheit is just right for methane and ethane to exist in all three phases. So if you think of water on the Earth being a liquid, solid, and gas, at minus 290 degrees Fahrenheit, it's just right on Titan for methane, ethane to be a liquid, solid, and gas. And what scientists speculated using those three pieces of information is a world very similar to Earth. Rivers, volcanoes, participants raining out of clouds, but the chemistry completely different. So how did we ultimately find what's down there? Three ways we found what's down there. First, we used special filters through the imaging subsystem to go through this haze particle and see and dig a little deeper to see down to the surface. The second is radar. And so radar allows us to find very, very smooth areas, such as lakes, because they will reflect it back and create very, very dark features. And the third way is send down the Huygens probe all the way down and ultimately land on the moon. And so this is our first composite image of Titan. And so ever since Huygens discovered this moon, this is really our first look. And you can see a couple of different important variations in the surface. You can see some very dark areas and some very light areas. If you're into conspiracy theories, that this is an alien base NASA's hiding from us, I'll foolishly go with the explanation they haven't yet mapped it. And this is a composite using all that different filtering visual technology. So up here is Titan, what it would look like if we're flying by in a spacecraft. This is that first, uses that filters to see the variation in the surface. And then here's a nice composite where it really shows the colors of Titan combined with some of that filtering. The second way to see what's down there is radar. And radar found evidence of cryovolcanism of ice volcanoes. Other instruments showed evidence that there's traces of ammonia at the surface of Titan. And when you mix ammonia together with water, you lower the melting point of water. And some of these radar images are another piece of evidence that there are ice volcanoes or cryovolcanism on Titan. Another thing radar found was dunes, vast expanses of dunes, very similar to some of the kinds of dunes on Earth. And the third way to see what's down there is the Huygens Probe. So the Huygens Probe was released in December 2004, descended down January 14, 2005. On its way down, it took pictures the whole way and ultimately lasted on the surface for a few hours. This is the actual descent imagery from the descent. So the Huygens Probe was let go of the Cassini spacecraft, jettisoned, and ultimately on the way down was swinging back and forth and took pictures the whole way down. So the Huygens Probe on its way down took this image. It landed in this horseshoe feature down in the right-hand corner. And this is one of the images it took on the way down. This is what I think of as Titan lakeshore property. So if you look at this image, there's evidence of channels, probably some kind of liquid that's carved these out over time. When it ultimately reached the surface had the consistency of wet sand. The sky was orange with patches of ground fog. This is a recent cover of Nature magazine. This shows that in the northern hemisphere of Titan, there's evidence on the order of 43 methane-ethane lakes. And this is a side-by-side comparison of the largest ethane-methane lake found on Titan and Lake Superior. All right, so to wrap this up, I wanted to compare Titan and Earth. Now, the atmosphere of Earth, mostly oxygen, some nitrogen. On Titan is mostly nitrogen and some methane. The erosion agents on Earth, wind, water. On Titan, it's liquid methane and wind. The surface materials on Earth, silicate rots and soil. On Titan, water, ice, rocks, and hydrocarbon particles. On Titan, volcanoes spew an ammonia-water mix, and on Earth, they spew lava. On Earth, if you drive a car, you use oxygen from the air, you have gasoline in your tank. If you were to drive a car on Titan, you'd have oxygen in your tank and gasoline in the atmosphere. Okay, so the idea today was really just to whet your appetite. The Cassini mission continues to be extended. There are literally new images and new discoveries every day. I encourage you to go to nasa.jpl.nasa.gov and check out the Saturn website. There are multiple discoveries. All of these videos and all the information that was in this presentation is available. If you'd like a PDF of this presentation, you're free to download it at LinkedIn, and also feel free to contact me at jplssa@comcast.net.